7.3, number 40. It tells us to use the shell method, so use the cylindrical shell method to find the volume of the solid generated by revolving the region bounded by the curves and the about the y-axis. Okay, so we're going around the y-axis. Y equals x squared looks like this. Y equals 2 minus x, that's the same as negative x plus 2. X equals 0 and x is greater than or equal to 0. Alright, so we've got this region right here. We're going around the y-axis. So if we're going around the y-axis, that means we're integrating with respect to x using the shell method. So notice we could use the disk method here, but it would require two different integrals because your r is going to be going out to this line, and then your r is going to be going out to this curve. So you'd have to set up two different integrals if you're using the disk. Or for the shell method, we may not have to use two integrals. So 2 pi r h, it's a vertical, so it's dx. So we need to know what is this x value right there, because we're knowing we're going from 0 to whatever that is. So if we set those equal to each other, x squared equals 2 minus x. So we got negative 2 and 1. This would be negative 2 and this is 1. So we're integrating from 0 to 1. Okay, so now we need our r and our h. Okay, so the first thing when we're using the shell is to draw an line segment through the region parallel to the axis of revolution. That's always going to be our h. And then connect it with the axis, and that's going to be our r. Okay, so now what is our r? Well, it's just x because it's going out from the y-axis and we're integrating with respect to x, so we can just put x there. And our height is going to be that minus that top minus bottom, that y minus that one. So this in terms of x minus this in terms of x. So it'll be 2 minus x minus x squared. And that'll be the integral. That's as far as I'm going to go on this problem.